Welcome back, everybody. In this video, in this lesson, we're gonna start our dictionaries lesson. Okay, so we'll learn how to create a Python dictionary, and we'll learn about dictionary operations, how to iterate dictionaries, and we'll learn about a very important topic on dictionary comprehension, and we'll do some practice. So let's get started. Okay, before we delve into Python dictionary, let's talk about a little bit on physical dictionaries. Okay, so a physical dictionary organizes uh, words alphabetically, right? So the search key is basically a, a word we want to know the definition, right? So that's the key. That word is key. So the respective definition is the value. Okay, so each each definition identified by a unique word, distinct word, and then that is the key. Okay. So this lookup is really easy because those all those keys are arranged in alphabetical order. So we know basically where to look. Okay. So and the physical structure of the dictionary book also designed in such a way that one can easily find that word. Like for example, the the letters are marked on the side of the book, those things, right? And really good content page, and you can simply follow the alphabetical ordering of the key. Okay? So Python dictionaries works the same. Okay, so Python dictionary is not sequential. Okay, so that means there's no index or there's no indexed item via a range of numbers. Okay, so it's really important to understand that it's not index. Okay, so it's not sequential. That's why we didn't call it a sequence when we talk about sequences. It's actually a map. Okay, so basically we call it associative collection. Associative mean there's a key associated to a value. Okay, so basically a key maps a value to it. Okay, so basically a key maps or associate a value to it. Okay, so in other words, we can say now it's actually ordered or indexed by keys. Okay, notice it's not, again it's not an integer number. It's just we commonly say keys, and in this could be, we learn that this could be variety of types, not just a number. Okay, so you can say that yeah, it is indexed or ordered by keys. It's actually a collection. Okay, the collection of key value pairs. Okay, so a container of key value pairs. Okay, so basically it's a set of key value pairs with keys being unique or distinct. Okay, all right, so the basically the main technique behind dictionaries is hashing, and it's the same for sets as well. Okay, so we learned about hashing previously, right? So in this case, in the dictionary case, dictionary maps keys, and these keys are hashable objects. Okay, and this hashable object, use this hashable object, which is a key, and then associate the values um, to that key. Okay, so a key must be hashable, but values may not be. So you can have values that are not hashable as well. Okay, but dictionary key must be hashable. So that means basically we cannot use list sets. So any mutable Python object as a dictionary key. Okay. In other words, we can use integers, strings, immutable tuple. So that means tuples with inside elements also immutable. Can use them. We can use a frozen set as a dictionary key because frozen sets are not uh, in, uh, they are immutable, right? Um, so and then that means basically any mutable object can be a key. Okay, we know that numbers are immutable in Python. That includes floating point numbers, but we usually usually don't recommend using floating point numbers as dictionary keys because there is an associated floating point error in in a key. So there's some uncertainty there. So it's good to avoid using floating point numbers as dictionary keys. Keys must be unique. So that means key duplication is not allowed. All right, so let's learn about how to create dictionaries. All right, so we can simply create a dictionary literal by enclosing uh, comma separated key value pairs in two curly brackets. Okay, so for example, I'm creating this simple dictionary. Okay, so values are first names, in this case Indika and Jenny, and these are the keys. So these two integers are keys. So this one pair is actually we call uh, an item in a dictionary. One of this pair is called an item. So in this dictionary we have two items. Okay, so we can simply enclose key value pairs in two curly brackets, and this is simply now a dictionary literal. Okay, so if you just use empty curly brackets, and it's going to be empty dictionary. Okay, all right. Okay, so let's continue. We can use dictionary comprehension, and we're going to learn it today later. Okay, we can use the dictionary type constructor. Okay, so like we had with list and tuples, dictionary also has a dictionary type constructor, and this is the name, and it's a built-in function. You can simply use it. Okay, so let's learn how to use dictionary type constructor. Okay, of course, if we directly use it like this, you're gonna create empty dictionary. Okay, so and if you use string, if your keys are strings, then you can actually use keyword arguments. For example, this dictionary, so if you pass your keyword arguments like this, see, notice that all of the keys are keyword arguments. To, of, at, these are like conjunctions or words in I think propositions in English. Okay, so I am using them as keywords, and then I pass the comma separated list of them into dictionary type constructor, and I will get this dictionary. Okay, all right. We can also pass an iterable of key value pairs into type constructor. Okay, so one is like this. So notice this is an iterable, so it's a list. Okay, it's a list of key value pairs. Okay, so each key value pair is either another list, can be another list, can be a tuple, right? So those things. Okay, so iterable. So this whole thing is an iterable of key value pairs. Okay, so I'll get the same dictionary. Okay, so again, guys, this is I'm using this as the return word for return. Okay, all right. And next, we can use a zip built-in function. It's similar to like zipping two things together. Like I have the set a list of keys, and I have the um, like sequence of keys. I have the sequence of keys. In this case, it's a list. I have a sequence of values. In this case, a tuple, and I am basically passing it to zip built-in function, and the whole thing going to get passed into dictionary method. Okay, so I will get the same dictionary. Okay, so it's a zip built-in function. So let's practice this out now. Okay, all right. So I'm gonna again I pre-formatted my PyCharm file. Right. So our first slide is slide 5, dictionary creation. Okay. So what I'm going to do is I'm going to create this dictionary simply by enclosing key value pairs. Okay, so let's check on that, and also empty dictionary. Okay, so I'm gonna put both of these. Okay, just empty dictionaries. All right, and I'm going to print the type of the dictionary just to verify they're actually dictionaries. Okay, so let's run this one. All right, so I got this as my dictionary, and I'm printing two empty dictionaries. One is just open and close curly brackets. Other one is just plain empty call to dictionary method type constructor. And I'm verifying the dictionary as a dictionary type. Okay. All right. So let's go back. So I'm gonna unblock this. This is slide number 6. Okay. All right. So let's unblock first. Okay. So creation. So this one keyword arguments. Okay. So I'm gonna simply pass this keyword argument list to dictionary type constructor, and the key is going to be each keyword and the values. Okay. All right. And here I'm going to test creating using iterables. Okay. But let me just first run this one and verify that. Okay. So it's right here. Okay. So I created this dictionary. I passed the keyword argument list, and I got the resulting. So 2 equals 5. And we can only use if they are actually, the keys are actually strings. Okay. And 2 and 3. Okay. All right. So let's test the rest of the stuff. So creating using iterables. Okay. So in this case, a list of tuples. So tuples are key value pairs inside. Okay. So I'm going to copy paste that. Okay. All right. And then this one, it's a list of list. Okay. So I think I made a mistake, or it should be, yeah. Okay. So I have the list, outer list, and inside also the key value pairs are also list. Okay. So list of lists. In here, a list of tuples. Okay. So let's check that on as well. Okay. So yeah, it's right here. And this one, tuple of tuples. Okay. So okay. And right here, tuple of lists. Okay. So you're going to check all of these. Okay. So list of tuples, got the same. List of list, I got the same. Okay. And tuple of tuples, got the same dictionary. Okay. And tuple of list. So basically inside this tuple, there are each item is actually a list. I think this should be there. All right. So yeah, that's good. So let me rerun. Okay. So we got the same dictionary. Okay. All right. So let's check the zip function now. Okay. So I'm gonna take this. So in with zip function, basically we take two. Usually the lengths are same. Two separately. Two sequences are separately. Like in this case, the keys are coming as a list, and the values are coming as a tuple. And we then zip them together and pass that into a dictionary. Basically, what zip does is basically create an iterator by zipping them together and then pass that iterator to dictionary type construct. Okay, so let's check this. Okay, so check on that as well. So we got the same dictionary. So now what? Let's see what will happen if we, if we remove some of these. Let's say, right? What if we remove this one? Right? Let's check on that. Just curious. Okay. Sippings, uh, unequal sequences, and check with that. See what happens. So it basically only picks what available from the keys. So add is not available. So this one is not there. So this value is not there. So because there's simply no key to associate this value. So I have this. And what if we do the same? What if we do the same? Now, let's say we are going to use a less value, one less value, right? So here also I'm going to remove. All right, so let's check on that. Okay. All right. Still I got the same, right? So now there's the extra key. So Python going to, neglect that. So 2 is 5, of is 2, and that's it. Okay. So it's kind of versatile. All right. So let's go back to our lesson. All right. So we were over here. Okay. So let's check on dictionary operations. Okay. All right. So it's a container. So you can actually get the length of a dictionary. Okay. So it's simply how many items do we have in the dictionary. So it returns how many items do we have in the dictionary. That means how many key value pairs. Okay. LEN function. If you pass a dictionary to a list, you can get a list of keys. Okay. So you can pass a dictionary to list method and you can get a list of keys. Okay. All right. So we said, okay, we can use the key as an index. Okay. So that means we can use it along with the index operator. Okay. And it returns the corresponding value. Okay. So if there's no key, then it returns a key error. Okay. So if so you can access a key, and then if you can also reassign or create a new key this way as well. So use the same indexing operator and pass the key, and if you if the key already have, and then if we put a new value, we can basically you can set a new value to existing key. If there's no key, then basically we are adding that key. Okay, so we are basically adding a key value pair. Okay, all right, so let's check on that. So slide number 7. All right, so I'm gonna unblock this. Okay, all right, so length. Okay, so simply use the len function, built-in function. Okay, and you can pass a list. Okay, so Yeah, so I'm going to, in this case, I'm going to pass this list to list function. I'm going to get a list of keys. Okay, so let's check on those two. All right, so length of the this dictionary is 2, right? I have two key value pairs, 1 and 2. Okay, and when I pass this dictionary to list function, I get the list of keys. So these are the keys, right? 1 and 2, just two keys. Okay, let's continue. All right, so now what I'm going to do is basically I am going to reassign the value. Okay, so I get this, and I'm going to let's say it's new is something like that. Okay, all right, so let's quickly print this one out. Okay, so the new one is this. Okay, see the value got changed. Okay, so let's try now. What I'm going to do now is I'm going to now try to access a key that is not existing. Okay, so let's try to do that. Okay, now you guys need to uncomment and run this. Okay, so and this will result in a key error. Okay, so I'm trying to access a key that is not existing. Okay, all right, so we got key error. Okay, so key error. So simply we don't have this key inside. Okay, all right. So yeah, so let's go back to, yeah, so I'm doing the same thing right here, right? So yeah, okay, so yeah, so we don't need to do this part, so I'm going to remove this part, the stuff we already did that. Okay, all right, so let's go back to our lesson. Okay, slide 8. So we are continuing on dictionary operations. Okay, okay, we can use the del statement to delete a key. Okay, so delete a key value pair basically. Okay, so and again, if the key is not there, we get a key error. Okay, all right, so we can also check membership. Okay, so basically a key, same way that we use in operator, we can check whether a key is a key value pair in the dictionary. Okay, if it is in there, and it returns true, otherwise false. It's membership check. Okay. We can use the get method of dictionary to get the corresponding value of a key. So basically we pass a key, okay, and we can pass this parameter called default. So basically if we pass default, and if in the case the key is not there, and the return value would be default. Okay, and if we don't pass a default, then the return value would be none if we don't have the key inside. Okay, so that means basically it doesn't return an error when we don't see the value. Okay, when we don't get the when there's no key inside. Okay, so if the key is not found, it doesn't return an error. Okay, so that basically that means get is a very good useful method in searching for keys inside the dictionary. Okay, so if there's no key, it returns the default value we pass. Okay, or if we don't pass a default value, the return value will be none, so nothing get printed or returned. Okay, all right, So we can use the items method to get a view object of key value pairs. Okay, so this view dictionary view objects are really interesting. They are actually dynamic, meaning it's like a range. Okay, so when we create these view objects, and you can pass this into a list and get the respective list. Okay, and once we create a view object, and when there's a change happening in your original dictionary, the view of the change going to reflect on the view object as well. Okay, so it's really good in that sense. Okay, let's check this out now. All right, slide number 8. Okay, so I'm gonna uncomment. um, okay, so we're gonna run the delete. Okay, so let's check on that. Okay, first checking the delete. So it's basically going to delete the key value pair, this key value pair. Okay, so run it. Okay, so now I'm printing the dictionary, so I only have the rest. Okay, so I'm gonna block this now for now. Okay, so let's now check the membership. Okay, all right. All right, so I'm going to check whether this key inside my dictionary. Okay, so 1 2 in dictionary. Okay, so let's check that out. Okay, and it is true. Okay, all right, it's in there. And now check for non-membership. So we're going to use not in operator. Okay, all right, so let's take this out. Okay, all right, so let's check for non-membership. So I'm expecting false here. Okay, so I got false because it's there, right? The key is there. Okay, so now let's check on get. Okay, now what I'm going to do is basically I'm going to check for 102 key, and I'm going to basically get that key. So basically I'm expecting here the value associated with the 1002 key. Okay, all right, so I'm not passing any default anything. Okay, so I got Jenny, right? So that's the value associated with this one. Okay, now let's take what I'm going to do now is I'm going to pass a non-existing key. Okay, so all right, so my expectation is nothing because I don't I'm not passing a default value, so the return value would be none because this key is not in there. Okay, so so this is our dictionary right here. This is our dictionary. Okay, let me put it here also so that we can see it clearly. Okay, all right, this is just simply overwriting. All right, so run it again. Okay, see that it's none. Okay, so now let's pass a default value. Okay, so what I'm going to do over here is, okay, so I'm going to pass this no such key. So it's kind of helpful. Like we can pass false over here. So there's a value here now, right? So in my case, I'm going to pass a error message sort of. Okay, so run it. Okay, right, right, no such key. Okay, so we can try passing false as a value. Okay, so let's try that out as well. So instead of this, I'm trying this one, and all right, So, all right, I got false. Okay. All right. So let's check on, let's see. Yeah, so we check that. Okay. Um, so let's check on the view objects. Okay. So items, view object. Okay. So this is the one. So we're going to use items dictionary method. Okay. And this returns a view object, and we'll see what kind of object we're going to get. Okay. All right. See that the name is this. Okay. Dictionary items. So it's how it returns. Okay. So this is what we get. Okay. So if we pass this to a list, and then we can basically print it. Okay. So let's do that. Okay. So what I'm going to do it, I'm going to pass this to a list method, and you can basically print the values, see the values. Okay. All right. Okay. See that? So I created a list out of that. So you can create a list of a pairs of items, right? So sorry, key value pairs. That means items. And notice they're actually those pairs coming out as tuples. It's really important to understand. Okay. So whenever we get those key value pairs as return values, they come out as uh, tuples. Okay. All right. Let's see. I think that would be it. Okay. Oh, you can actually check the type of those. Okay. So I'm gonna that's what here I'm going to check. Okay. So type of those values. Okay. Um, so this is the type of the this will be dictionary view type. Okay. So let's verify. All right. Let's go back to our slides. So we go over here. So guys, check this link and you can read more about view objects over here. Okay. All right. Continue on our lesson on dictionary operations. Okay. All right. So you can use keys method, not keys, and you can get a view object of all keys. Okay. You can pop an element, so that basically if you when you pass a key, and then basically Python going to remove that key from the dictionary. Okay, that key value pair from the dictionary. Okay, so so basically when it does it, it actually returns the return value. Okay, so that's why I said it's return. Okay, it returns, it removes that key value pair basically, and returns that value, keys value. Okay. Again, you can pass an error message over here too. Okay, so um, uh, it Python returns default this value whatever we pass if no key, or if we don't pass, and we'll get a key error. So if we don't pass a default over here, we're gonna get a key error. Okay. All right. So we can also use pop item. Okay. Pop item returns key value pairs in LIFO order. So what is this LIFO order? It's an acronym called last in, first out. Remember we said dictionary has an order, right? So basically, as we put item into the dictionary, it's gonna basically place them in like the way we actually arrange, let's say like a pile of coins. Okay. So basically, the last one we put on the pile of coin is the last coin, right? And if we take out a coin, basically we pick the last one. So last in, first out. Okay. So last one we put in. If we want to take out something, first out would be that last coin. So it's the LIFO order, LIFO. and we call this kind of data structure stacks. So it's so in dictionaries, but this guys, this is how this Python did this only after version 3.7, including 3.7. So basically, when we create the dictionary, we're gonna store key value pairs in this order. So the last key value pair will be sitting on the top of the stack. So it's similar to stack data structure. Like not all the way. It's kind of similar to the basically ordering is similar to a stack data structure. Okay. So we call it LIFO, LIFO, last in L coming from last in I and first out F O out. Okay. So basically, if there is no key array again, and basically key error if it is empty. So, but sorry, let me take it back. If the dictionary is empty, you're gonna get a key error. Okay, and this method is really useful in iterating a dictionary in a destructive, basically destructive iterating. As you iterate, you take out items, and then at the end, you're gonna get empty dictionary. Okay, we call it destructive iteration. Okay. Right, so you can also get this method, values method, to get a view object of values. Okay, let's check this out. Okay, so number 9. Okay, so let me see. Okay, oh yeah, so let me just check this. All right, slide number 9. Okay, oops. All right, so view object of keys. All right, so we'll get a view object. This is the one. Okay, so it's the way they name it, dict keys. All right. Okay, and let's pop a value. Okay, so in here, okay, so what I'm going to do is I'm going to pop a non-existing item. Okay, so let's do that. Oops. All right, so this one, this the command on it. Okay, and we'll get an error message. Okay, so it's kind of similar to delete. Okay, all right, so let's see. We got the error message, no such key. Okay, so let's do this in let's use pop item. Okay, so what I'm going to do is I'm going to uncheck this, all this. All right, so I'm going to pop item. So before that, I'm going to print the dictionary. Okay, so okay, so right before popping item, we have the entire dictionary, and I'm popping out now. So it returned the popping out item. So the resulting dictionary doesn't have that item now anymore. Okay. All right. So let's check. Um, Now let's check on values. Okay. So I'm going to create a new dictionary here. Okay. So dictionary 2. So I'm going to use the keyword arguments, create that. Okay. And then in values view object. Okay. All right. So let's check on that. Okay. So I got the dictionary values view object. Okay. So okay. So what I'm going to do now here is basically we gonna, yeah. So let's verify the type of this one of this pop item value. Okay. All right. So the type, okay. All right. So this will be a tuple. So let's check on that anyway. Oh, okay. There you go. So I need, yeah. See this class tuple. So the item inside of a dictionary are actually tuples. So I'm popping an item, so it return, and we saw that it returned that item, right? See this one? It's a tuple. So we verified that. Okay. Okay. So let's now, uh, I'm going to show you this destructive iteration. Okay. So what I'm going to do is I'm going to use a while loop. So I'm reassigning the values. So dictionary 2. Okay. So I'm going to demo the destructive iteration using while loop. Okay. While. Okay. So dictionary 2 not equals, not equals, what can we use over here? Not equals empty dictionary, right? Dictionary. Okay. All right. So I'm going to now pop item. Okay. So let's do that. It's over here. Okay. And we can print it. Okay. So print. All right. So let's check on that. Okay. All right. So we basically got all the item out. So the dictionary before is this. I have all 3 items. I take them out one after the other. Okay. All right. And notice the order they came out is the LIFO order. See, this is the one when I create that dictionary. This is the order that I created. So this one goes first, then this and this, right? So this key value pair is sitting at the top, and this is the last item on the top. So I took it, pop item basically took it out first, and then go, and then next one is that likewise, right? See the order, the first one out was the last one in. Okay. All right. So before order, and at the end we have the empty dictionary. Okay. All right. So let's check. I think that, yeah. So let's go back to our slides. Well, didn't we check the values? Did we check the values? Yeah, over here we check the values. View object. Okay. All right. So dictionaries are orders. We already saw that, right? Okay. So they preserve insertion order. Okay, but that comes after only after version 3.7. Okay. So basically acts like a stack of items. Items are key value pairs. Okay, like you can think of like a um, coin stack. And when you try, you cannot try to remove from the sides, right? So um, we can do it using pop, okay, or even delete. But in this case, in case of pop item, it's coming out from the top. Okay, all right, it's leaf forward. So updating a key does not affect this order. So you can check this out as well. Okay, so let's say you change a value related to a key, and this not gonna change the order. Okay, but if you delete a key and add it again, now the inserted new one is going to go sitting on the top of the last one. Okay, so basically once you delete a key and add it again, it's going to insert it from the end or from the top. Okay, So both dictionaries and dictionary views are reversible. Okay, so you can basically pass the dictionary to reversed method, and then you can get a you can reverse it. Okay, so let's check on these now. Okay, so slide number, see, number 10. Okay, all right, so let me create this list, sorry, dictionary. Okay, so we have this one, and we're going to check on the order. Okay, so that's what we have here, right? Preserve insertion order. Okay, so let's check first. We already checked that. If you take out, if you pop item this one, so we're gonna get this out. Okay, so let's check on that. Actually, we have it over here. So right here. Okay, okay. So we're gonna check that. Okay, so run it. Oh, again the wrong dictionary. So let's check right here. Okay, okay. So we printed that last one, so the last item. Okay, so now basically, let's say now we change something, like I'm going to recreate this. I'm going to reassign the values to this one. Okay, okay. So let's change the value of this one of these key, right? So I'm going to do two. I'm going to pick the value of off. Okay, and that's going to get equals to, say, like 10. Okay, so now let's print that. Okay, so print before and after change. Before change. All right, and after change. Okay, so okay, after change. Okay, so I'm printing before and after, and we'll see that the ordering is going to be same. Okay, so before change is this. Okay, see that this is not in sitting right here, right? So it's sitting the same at the same place. Okay, so the order is not changed when you change, when you um, change that item. Okay, so let's now delete an item and re-add that. So I'm going to use del. Okay, and I'm going to remove this item. Okay, all right. So I'm going to now sorry, this one after delete. Okay, all right. So after delete. Okay, all right. So we have this. All right, so it's gone now. Okay, so now I'm going to add the same key value pair. Okay, the same thing that we deleted. Okay, all right, so then I'm going to print it again after add it again. Okay, okay, so let's run it. Now you can see that they are sitting at the end or the top. Okay, so that's what it says. Okay, so when you delete a key value pair and re-add them, so it's going to change the order now. Okay, it's going to be sitting at the top. Okay, makes sense, right? All right. Um, all right, so they are all reversible. So the method we have to use is actually reversed. Okay, So let me uh, reverse this. Okay, so we have this dictionary. Okay, so reversed, um, reversed, it should be reversed, and we're gonna pass the dictionary. Okay, so let's bring this one, see what we'll get. Okay, so all right, so that means, oops, so this is the command. Reverse, it's a built-in function, guys. Okay, so um so put this one over here too. Okay, all right, so reversed. Okay, all right, see this, it's an iterate object, so we call it iterate object. Okay, so what we can do is we can pass an iterator to any sequence type constructor method like list or string. Then we can get a if it is a list, I can get a list of reversed items. Okay, so let's check on that. Okay, so I'm going to simply pass this to a list. So we can see like the possibilities are enormous. Okay, all right. So I get off at 2. So it's basically I'm getting the reversed list of keys, right? Right. So this is, see, off was at the end. Now it's at the top, at the beginning, and it's middle. Now 2 was at the beginning. Now it's at the end. Okay. So basically you can get a reverse iterator object by passing your dictionary to reversed method. Okay, and you can do the same with dictionary view objects as well, and that's really important. So let's check on that as well. Okay, all right, so what I'm going to do is I'm going to pass now, I pass the dictionary over here, I'm going to pass the values. Okay, values, let's see what we get. Okay, so that also, so we get a reverse values, right? So these were the values, and we get reverse values as a list. Okay, so well, we can try out other sequences as well. You can try a tuple. Okay, so let me try a tuple over here. Okay, so I haven't checked this one, guys, so I may be wrong here. Let's check that. Okay, all right, so you get a tuple, right? So let me try a string over here, but that I'm not sure though. Okay, okay, so string str, all right, let's try it. Oh yeah, but it's just a we didn't get a string of those things, right? So it's kind of printed the name of the object. Okay, that's all, right? Okay, so it's basically the string, it's printed the string representation of the reverse iterate object, which happened to be the same thing that we returned over here. Okay, all right. Okay, so let's go back to our slides. Okay. All right. Dictionary can be compared for equality. So the comparison is possible, but only equality or not equality. Okay. So it means basically if we uh, have two dictionaries with equal key value pairs, okay, um, regardless the ordering. So ordering could be, you know, jumbled. That's fine. But if we have the same items in both dictionaries, that means same key value pairs in both dictionaries, then will return true in comparison check. Okay, all right, but none of these are not working, so they are not defined. Okay, so if you try to do this, and we get a type error. Okay, so let's check on these two. Okay, okay, so let's right here. So I'm going to create a new dictionary. Okay, all right. So dictionary 3. Okay, and notice it's the same. It's going to be similar. Okay, so now I'm going to print both dictionary 2 and dictionary 3, and I'm going to verify first that they are actually two separate. Okay, okay. So yeah, so these are two. Basically, there are two separate dictionaries which happen to be same key value pairs. Okay, and that, so this is means basically it false. That means there are two separate dictionaries and happen to be the equal. Okay, so what we can do is basically we can, let's say, remove this and then change the order and then check it again, and we'll get the same result. Okay, so in order independent. Okay, so let's do that. Okay, so what I'm going to do is I'm going to delete. Okay, so um, this key, so I'm going to remove at. Okay, all right, tell this, and then we're gonna add it. Okay, and so that means basically I'm now changing the order. Okay, equals 3. Okay, all right, so so let's do it all these. All right, so let's do it over here. So where am I doing this? Okay, so this should be over here. Okay, so all right, so um so this should be dictionary 2. Okay, yeah, okay. Now, so now I added this. Okay, so we can actually print it. Okay, so now let's check the check both. You don't need to check that, you only need to check this. Okay, so I'm expecting still true over here. So now I change the order. Okay, so we can print both. We'll see that order is changed. Okay, so run it. Okay, so as you can see, same key value pairs, but the order is now different. In here at and 3 over here, and here it's in the middle, but they are equal. Okay, so it's order independent. So we just proved it. Okay, all right, so let's check the others that we can check, uncomment one at a time. Okay, so and all of these return type error. Okay, so it's a type error. It's not basically this is the type error. Okay, so I'm gonna comment out. Okay, and you can uncomment and check all of these. They're going to return type error. Okay, so it is only equality and not equality are allowed. Okay, so we can tie the not equality over here. So let's tie that out as well. So oops, real quick. Okay, so not. Okay, and I'm expecting false here. Okay, so this should be this. Okay, so that operator also works. Okay, let me just yeah, check this out. False. Oh, that's misleading. Run it again. See that it falls. That they are equal, right? So it means basically this and this only works in comparison, not these. Okay. All right. So let's go back to slide 12. All right. So how do we iterate a dictionary? Okay. So you can use the keys to iterate. So simple rule is basically you can use a for loop and then keys, and for keys in a dictionary. So basically um, keys acting like sort of index, right? In a dictionary. So we have a dictionary over here and we can do whatever we want to do inside the for loop inside. Okay. So here's a simple example. I'm printing out all the keys and this is my dictionary, and for keys in dictionary and print out the keys. Okay. All right. So let's check that out. Okay. So the syntax. All right. So I'm going to see. All right. All right. For keys in, say, dictionary 2. Well, let's check now 2 and it's just print keys. All right. And we don't need this line. All right. So you can use a while loop, but it's you can destructively iterate using while loop. Also, you can use oh, I think I bypassed this one. So we can also view object as well. So let me just copy this, just cut paste this over here. Okay, so go in here. All right. Okay. So the next slide, we can also use a view object to iterate as well. Okay. And you can try while loops as well. Okay. So I mean, while loop kind of tricky, right? Because we need that condition. We need to create that condition. So you can use a dictionary view object to create that condition. Okay. The loop ending condition. So let me just, okay. So you can iterate a dictionary indirectly. So because we are actually essentially we are iterating the view object. Okay. So dictionary view object, and we can do something there. Okay. All right. So this is an example. So for items in here, so this is the view object, and this view object return items, right? So for items in here, and in here I'm printing those items. So I'm going to get those 2 items there. Okay. So let's check this out real quick. Okay. So basically this, we don't need syntax. For items in 2 dot items and print items. Okay. So on this one, so I get all the items I have. Okay. All right. And let's continue. Okay. All right. Much anticipated dictionary comprehensions. Okay. So similar to list and set, dictionaries also support comprehension. Okay. Whenever there is a creation of a dictionary, more often you can apply this technique as well. So it's a one line creation of a dictionary. Okay. So if clause is optional. Okay. So basically we have this is the syntax. Okay. So it's similar to list. The only difference is we're gonna have two expressions, one for the key and one for the value. Okay, because for end of the day we have to have key value pairs for the dictionary. So we need to create those key value pairs in our comprehension. So that means we're gonna have two expressions, one for the key, one for the expression. And the rest are similar for items in sequence. So we get a sequence, and there's going optional if condition. Okay. So, and if clause is optional. Okay. So expression 1 and 2 basically describe the key value pairs. How are we going to form them? Okay. So for clause basically iterate through the sequence. Okay. It could be a string, could be a list, could be another dictionary. Okay. So all right. And if clause basically print filters elements um, according to a condition. So I should have say items. Okay. Well, elements from sequence. Yeah, it's correct. Okay. All right. So let's check on that. Okay. So I think, yeah, this is the slide that we're gonna do a comprehension. So let's read the question. Okay. Okay. All right. So practice. So here's the question. Given a list of numbers, create a dictionary by associating the powers of 2 of all even numbers. And this has some practical application, right? Imagine you have this thing. You need powers of numbers of a huge list. Okay. And imagine like if you are having to calculate these powers in a program again and again, and that's going to be expensive process. But what happen if you save those powers in a dictionaries? Notice dictionary lookup is order one. Basically, it's a single CPU instruction. It's the same thing with sets. Okay. So set and dictionary lookup, because of that hash value and key, we use keys mapping to pick the value. Basically, it's a single CPU instruction. So that means it's really efficient. So if you pre-build this dictionary and save it somewhere, and then when you need that power of that whatever the number, you can simply look it up in the dictionary using a single CPU instruction rather than a lengthy search procedure or calculation itself. Like calculation power of a large number could be expensive. All right. So so that's the sort of problem we have. So we need to create this dictionary using comprehension, and this is the code basically. Okay. So I'm gonna take this code. Okay. All right. So get only this, and let's work it out the rest. Okay. Okay. Right here. So I have the list of numbers. Okay. So I need to print the dictionary result, something like that. And it's a dictionary, right? So how do we create it? First, any comprehension, just start putting the respective bracket. If it's a list, put 2 square bracket. If it is a set, 2 curly bracket. Dictionary, again 2 curly brackets. Okay. Now what I'm going to do is I'm going to first put the for statement. Okay. So something that you know, right? So there has to have a for. So for, well, numbers in this list. list of numbers, and there's an if condition. Okay, so basically if not that number, so basically if we need only odd numbers, powers of 2 of all even numbers, sorry, all even numbers. Okay, so basically we know how to get the odd evenness, right? So basically it's if not these numbers mod 2. Okay, all right, so numbers, this is the number. If we take this mod 2 value, this is going to be 0. If that is say only even numbers, so yeah, so so not 0 means, see, this is 0. Yeah, so we don't need that. Not, let's try again. All right, so we need to basically get that number. Number is going to be the key, right? So what's going to be the value? Okay, value is going to be the power of that number. So let me read the question again. Associate the powers 2 of all even numbers. Okay, so all even numbers. Let's check that. Okay, so numbers to the power 2. Okay, as in let's see, numbers, and BER is numbers. Yeah, it's good now. Okay, so let's check this is out now. Okay, so we got odd ones, right? I think this should be not over here. Yeah, that's why. Yeah, all right. So because this 0 returns false, right? So it means it when not going in there. So I need to have not over here. So not 0 means it's actually not false. That means true. Okay. So check that. So I got the even number and its power of 2, 4. Even number 8 is power of 2, 64. Even number 4 is power of 2, 16. And the rest are basically well, notice, right? So we have repeated values like 2 twos over here, right? 3 twos, right? But we only have one key, right? Remember, right? It's the way dictionaries and sets work. There cannot be 2 repeated keys. Okay, all right, so that's it. So that's the result of the comprehension. Okay, all right. So the next question, I'm going to do it in a separate video. Okay, guys. All right.